Our last question is number 11. This is where we have systems of quadratics. So something like 2x squared plus 7x plus 12. And then maybe something like y equals, I don't know, x squared, let's say 3x, and 9. See if those two work. So what we do for this is both of these are equal to y. Well, y is the same thing, so that means that they're equal to each other. So we can swap them out, and in the place of y here, we're allowed to put what y equals. So 2x squared plus 7x plus 12 equals x squared plus 3x plus 9. So in a balance, these things are equal to each other because they're both equal to y. It's like saying, well, the top equation is worth 25 and the bottom equation is worth $25. So because they're both worth 25, then they must equal each other. So they equal the same thing. Therefore, logically, they also have to equal each other. So now that we're in this form, we want to set it equal to 0. So everything that's on our right side over here, we need to move it over. So minus x squared, minus 3x, minus 9. When we do this, we'll get x squared, positive 4x, positive 3, and there's nothing left on this side. It all simplifies to 0. We've taken it all away. So we can put this on a box right here. When we factor this, we'll get x plus 3 and x plus 1. And then we can bring these into their individual points and set them equal to 0. So subtract 3 from both sides, x equals minus 3. Subtract 1 from both sides, x equals minus 1. Now we're not quite done because we need a y value for each of these. We need to plug that x in. So let's go back. We can use this equation, x squared, 3x, and 9. So x squared, 3x, and 9 for both. And then we can take these values and plug them in. So positive 9, minus 9, positive 9. Or in this case, y just equals 9. Minus 1, minus 1. So in this case, 1 minus 3 plus 9. Or y equals positive 7. All right, so final answer for this is negative 3, 9, and negative 1, 7.